to start a section on trigonometry, which is the relationship of the sides of right triangles. And we're going to start with we're going to go back to a couple chapters and pick up one section that we didn't leave because I felt like it went better here. And that is the relationship of special right triangles. And that's triangles that are 45, 45, 90. So the two, it's a 90-degree angle, of course, because it's a right triangle. And then the acute angles are 45, 45. And the other one is 30, 60, 90. So we've got a right angle again, and then the acute angles are 60 and 30. All right? So the cool thing about a 45, 45, 90 triangle is, of course, it's an isosceles triangle, because remember, if the angles are the same, then the sides that are opposite those angles are the same. So whatever this side is, this side has to be the same. So if this is 4, this is 4. If this is 9, the other one's 9. They're always the same. And the hypotenuse, because remember, the hypotenuse is the side across from the right angle. So if you put your pencil in the corner of the right angle, draw a line out, that's the hypotenuse. It's always whatever the side length is. So in this case, it'd be 4 times the square root of 2. So if these two sides were 4, this would be 4 square root of 2. Okay? Let's try a couple of these. So if this is a 45, 45, 90 triangle, then the two angles here are equal, so that means the sides are equal. And the hypotenuse across from the right angle is whatever the sides are times the square root of 2. All right, take a second and do the other two. Okay, so these sides you probably got pretty easily. You know that the sides are always the same. So if this is 4 square root of 2, this is 4 square root of 2. If this is 3 square root of 6, this is 3 square root of 6. Just remember the rule. The hypotenuse is always whatever the side is times the square root of 2. So in this case, it would be 4 square root of 2 times square root of 2. Square root of 2 times square root of 2 is 2. So 4 times 2 is 8. So the length of that hypotenuse is 8. Over here, 3 square root of 6, 3 square root of 6. The hypotenuse is 3 square root of 6 times the square root of 2, which is 3 times the square root of 12. The square root of 12 is, I know this gets complicated, it breaks down into 4 times 3. The square root of 4 is 2, so it's 2 times the square root of 3. And then, so you have 3 times 2 times the square root of 3, which is 6 times the square root of 3. All right? And this one I wanted to do together because it's also a little different. Remember, this 12 is whatever the sides are times the square root of 2. So let's call the sides x for now and say x times the square root of 2 is equal to 12. Well, if you solve for x, you would divide by the square root of 2. Okay, those would cancel, and you get x is equal to 12 divided by the square root of 2. Now remember, square root of 2 on the bottom of a fraction isn't allowed. So to get rid of it, I'm going to multiply the top and bottom by the square root of 2. And I get x is equal to, again, 12 times the square root of 2 over, and the square root of 2 times the square root of 2 is 2. Then I can divide the 12 and the 2 because they're both outside the radical sign. So I get x is equal to 6 square root of 2. So this side is 6 square root of 2, and this side is 6 square root of 2. All right? Okay. So that's for a 45, 45, 90 triangle. Now, the 30, 60, 90 triangle works kind of the same way, just different relationships of the sides. Now remember, back to chapter 6, when we talked about the characteristics of triangles, the shortest side is across from the smallest angle, medium side's across from the medium angle, largest side's across from the largest angle. So the smallest side is 30, or the smallest angle, so it's going to be across from the smallest side, x. The medium angle is 60. It's going to be across from the medium side, which is x times the square root of 3. Remember, the square root of 3 is like 1.2. So, like, if you just estimated, this would be like 1.2x. Okay? And then the largest angle is across from the largest side. And obviously, 2 is larger than 1.2, so that 2x is the largest. So now that I've marked this up and it's hard to read, so every single 30, 60, 90 triangle has this relationship. The side across from 30 is x, the side across from 60 is x times the square root of 3, and the hypotenuse is always 2x. All right, so let's do a couple examples here. We know this is 30. The side across from 30 is 5. That's the smallest side. The side across from 60 is whatever x is, so in this case 5, times the square root of 3. And the side across from the hypotenuse is 2 times whatever x is, or 10. Okay? Why don't you take a second and see if you can figure out these two triangles. Again, remember those rules with square root. Okay, so to start with this triangle over here, we've got the side across from 60 is 10 square root of 3. The side across from 60, remember, is x times the square root of 3, so x must be 10. So we can put 10 here. Then the hypotenuse is 2 times x, so it's 20. Okay, this one over here gets a little more complicated because the side across from 60, the x square root of 3, is 6 square root of 2. So we do just like we did up above. We said x square root of 3 is equal to 6 times the square root of 2. Then we solve for x. So we divide both sides by the square root of 3. So x is equal to 6 square root of 2 over square root of 3. To get the square root of 3 out of the bottom of the fraction, we multiply top and bottom by the square root of 3. So that gives me 6 square root of 6, because those two can multiply, over, and then the square root of 3 times the square root of 3 is 3. 6 divided by 3, those are both whole numbers. So I can divide them, and I get 2 square root of 6. Okay? Then, so that's x. Then, remember, it's across from the hypotenuse is 2 times x, so it's 2 times 2 square root of 6. 2 times 2 is 4, so it's 4 square root of 6. All right? Take another minute and do these two. Okay, so we got 5 square root of 3 for the side across from 30 on this left-hand triangle, and 10 square root of 3 for the hypotenuse. And on the right-hand side triangle, we've got 3 as the side across from 30, and 3 square root of 3 for the side across from 60. Okay, and then finally, this is kind of useful if we put it together with some of the stuff we know, and that is, if we have a isosceles triangle, we know that the altitude bisects the sides, okay? And we know that these two angles have to be equal. And since it's equilateral, we know that every single one of these angles is 60, so 60 and 60. This one's 62, but it's bisected, so that makes this one 30 and 30, all right, which, because it's an altitude, this makes it a right triangle, it's a 30, 60, 90 triangle. So the side across from 60 is 30 inches, so I can say that x times the square root of 3 equals 30. Divide both sides by the square root of 3. I get x is equal to 30 square root of 3 over 3, which is 10 square root of 3. So the side across from 30 is 10 square root of 3. And then the hypotenuse is 2 times that, so it's 20 square root of 3. So if I do 1/2, the area of a triangle is 1/2 times base times height. All right, so the base is 10 square root of 3 plus 10 square root of 3, which is 20 square root of 3, which makes sense because it's equilateral, and we already know this side's 20 square root of 3. So then times 20 square root of 3. I'm sorry, that's wrong. It's times the height, which is 30, because remember the height is perpendicular to the base. So I'm going to multiply this. 1/2 times 30 is 15. So I have 15 times 20 square root of 3. And 15 times 20 is 300. And so the answer is 300 times the square root of 3. Okay, and the perimeter, which is kind of what I was doing in my head there, is 20 square root of 3 plus 20 square root of 3 plus 20 square root of 3, which is 60 square root of 3. All right, and that is 30, 60, 90 triangles. And 45, 45, 90 triangles.